Hi, in this video I will show you that if a matrix has a row which is multiple of another row or a column which is a multiple of another column, then the determinant of that matrix is going to be equal to 0. Well, before we had a result which is a special case of what we are going to prove, and it said that if two rows or two columns of a matrix are equal, then the determinant of that matrix, let me say A, is going to be equal to 0. Here now we want to say even more. They don't need to be equal to each other. Even if one is multiple of the other one, then the determinant is going to be equal to 0. Well, let us assume that row I is C times row J. And well, then we can start from A and do the row operation Ri minus Crj and generate matrix B. First of all, this operation, this elementary row operation doesn't change determinant. And also, we know that by this operation, what we did here, subtracting C times Rj from Ri, B is going to have a 0th row. Well, if that's the case, then we know that if a matrix has a 0 row, you can expand along that and get determinant of A, which is equal to determinant of B, equal to 0. Okay, so let me write this as a theorem or a fact or a result, corollary, that if a row or a column of a matrix A is a multiple of another row, or in the case of the column or another column, then determinant of that matrix is going to be equal to 0. Well, we showed it for row. You can do exactly the same thing for column, but well, you have to do elementary column operation. Well, knowing this fact and facts like this are sometimes very helpful because it just makes you, well, you don't need to do lots of new computation. If you note that there is a row which is multiple of another one, then you just go ahead and then write it 0. For example, here you see row 1 and row 3. If I multiply row 1 by -2, we get row 3. So row 3 is a multiple of row 1, then the determinant is equal to 0. Or look at this other one, column this time, column 1. If I multiply column 1 by 3, that will give us column 3. Yeah. And well, using the fact about a theorem about this is going to be equal to 0. I didn't do any other computation, just that is enough. Okay, so this is another fact that sometimes is very useful to know and use it.